In today's lesson, we'll learn about electric charge. The main idea is that this electrical charge is a property of atoms. Charges that have the same type will repel each other. Opposite charges will attract. Now, this is something that you have observed in your daily life. If you've ever walked across a carpet on a dry winter day and reached and touched a metal doorknob, you'll feel a shock. Your shock go from your hand to the doorknob. That's the electrical charge that's built up on you. There are many examples of this, and in the launch homework for tonight, we've asked you to come up with a few examples. If you've ever been down a plastic slide in a playground, you feel your hair standing up on end, then you know you touch that piece of metal, oh gosh, I'm going to get a bad shock. There's that. Other examples are things that you can think of yourself. So in this chapter, we're going to talk about something called electrostatics. That's the study of electrical charges that can be collected and held in place. These charges have forces between them. You can observe this in many different ways. Figure 1 here in the book is an example. If you rub hair with a rubber balloon, you'll see that there's charge transferred between the hair and the rubber. There will be an attractive force. You can see in this case the fur of the cat is being attracted toward the rubber balloon. So the force, electrostatic force, is a lot greater than the force of gravity. It's much, much stronger. So in the second figure in your book, there's a video. It doesn't work well on the screen recording. Play it yourself. You'll observe some examples of how you can transfer electrical charge with sticky tape, with transparent tape. We are going to do this activity. If you have some Scotch tape yourself, I highly encourage you to do this on your own. You will observe a video of me doing this activity in class on the next day. You'll see what happens is that with the tape, if you prepare it in the same way, if it has the same charge, the pieces of tape will repel each other. If they have opposite charges, then they will attract each other. You could use this for further investigation. You could see if another object has the same type of charge as one piece of tape and the opposite charge from another. So in doing these types of investigations, you can see whether what type of charge things have. What you'll observe is when you rub two objects together, there will be a transfer of charge. We don't create or destroy electrical charge. What happens is that a charge will transfer from one object to another. Now at the microscopic level, we know that what happens is that atoms have a positive charge. The nucleus has protons and neutrons. The protons have a positive charge in the center. Around that is surrounded by electrons that have negative charge. The negative charge, the electrons, are the things that can be transferred. When you rub two objects together, what will happen is some of the electrons are pulled off the atoms. They will go on to one object which has excess electrons and negative charge. The other object will have a shortage of electrons and thus have a net positive charge. So do remember that. We will talk about this. We'll talk about this a lot in the class. The thing that happens, the things that transfer are the electrons. The protons themselves do not transfer. You can see in this figure 4 here some of the phenomena of what happens if you're walking across a carpet. The electrons from the carpet will transfer into your shoes. Then you build up with this excess electric charge. We have a FET activity called John Travoltage that shows how this works. You can see how this process works. Similar thing happens inside thunderclouds. All the air currents and water droplets and dust particles within the thundercloud will cause transfer of charge from some of the particles to others. You wind up with very large separation of charge, negative charge down near the bottom, positive charge at the top. that will neutralize in large lightning bolts, sometimes between clouds, other times between the bottom of a cloud and the ground. Now, solid materials come in different types. We define an insulator to be a material where the charge does not move easily. In these cases, you have something that where the electrons are tightly held to all of the atoms. Materials like glass and dry wood, most plastics, cloth, these are all good insulators. On the other hand, other materials, metals are called conductors. A conductor is something where you can have a material where some of the electrons are not bound tightly to one of the atoms. They can move easily through the solid material. So if you were to somehow get some electrical charge in it, the charge will move very easily across it. So you can see if you build up excess charge on an insulator, you can see in figure 5, the charge tends to just sit on one side of it. On the other hand, with a conductor, the charges all repel each other. They will move around. They will distribute themselves until they're equally spaced across the conducting material. All right, so with that information, you should be able to answer the questions on the launch homework. I encourage you to start. If you have other questions, we'll discuss this in class the next day.